Hi everyone, it's Friday the 13th and I'm home with a sick kid again. So, what you guys are going to do is finish up your lab. So, the first thing you're going to do is when this is over, you and your group are going to go in the room, get out your cups of apple cores, bring them to your station. You can get forceps over to the right by the college board. There's a beaker or tin of them. Just go ahead and take a pair of forceps. You can use them to take out the apple cores. Use a massing boat and get their final masses for me. Record that on your data table. And speaking of your data table, this is how I'm going to do it. The temperature will be 21 degrees Celsius. You'll have to convert that to Kelvin later. Not a big deal for now. Put that in your lab notebooks. 21. Initial mass you already have down. Final mass put down. Find the percent change of mass. Of course, this is the big one here. You need one of these for each of your tables. And this is my old table I used to use. We're not using 0.0, so again, not worried about that. You can have a table like this in your final report. That's totally fine. And that's what I want to talk about now, about your report. So you have this little hints thing you have here. The reports are going to be due Tuesday. Monday during the second period, it's a double period class, I will spend time answering your questions about the lab or the upcoming test on Wednesday. So here's a couple little tidbits you guys should follow. Number one, when you do the introduction, all right, the background research, give me something about your apple variety. If you did Gala and Empire, do a little research, find out what you know about them, how they were bred, when they were bred. You're not going to get a lot of nutritional content from that. That's okay, but give me some nice information from that, and make sure you cite that. Also, you must include something about water potential. You can use the lab itself, the beginning of the lab itself, for some information on that. You can talk about concentration of water going across on either side of a membrane. The terms hypotonic, hypertonic, isotonic, which we'll talk about on Monday. Their introduction needs to have that. For your variables, please, if I made some corrections in your lab notebook for your pre-lab, use them. Independent variables, dependent variables, specifically what you're measuring, and as many things as possible that you're keeping the same, the constants. And one of those, of course, would be, let you guys said something about the apple cores. Be specific on what you meant by that. For your hypothesis, basically it's which apple you think is sweeter. And that's where you have to use the data from. Your methods is basically summarizing all of the information that we gathered from the procedure, and that's not that hard here. There were some changes up here. Of course, we used 20 mils, not 25 mils. This is an older version of that, but that's totally fine. The results. Big part of your grade is the results. You must open up with what you found. Give me that bold sentence of what you found to be the sweeter apple. And then you must give information, all right? You must be able to use the information, the graphs that you get, to figure out the osmolarity. We went over this in class. I showed you guys the graphs that I wanted. It should look something like this. If say this, I made up data here. This is just made up here. You have the molar solutions, you have the percent change of mass, you have your line that you made, the trend line. There's your y equals mx plus b. Okay, we're trying to find, again, right there, where y equals 0. We're trying to find what x is, because that best fit line, that regression line, where it crosses the x-axis, that right there is osmolarity. That's something big right there. Oops, wrong one there. That's the osmolarity, okay, where it crosses. That's giving you the relative molar concentration of how much sucrose is there. So that right there is telling you which apple is sweeter, okay? Now, here's one thing I didn't talk about yet, and it's just a calculation. Once you've figured out, using math, what the osmolarity is, please figure out the osmotic potential, okay? The solute potential, it's the same deal, okay? We're using sucrose. This C right here, well, that's what you found for each apple, whatever that value is that cross, because you're going to have two lines. You're going to have two lines. This is just showing one. The other line might be over here. Who the heck knows? But each line is going to represent an apple. So I want you to put down in your results to clearly state what the osmolarity is and then also what the osmotic potential is. Little hint here. The greater the molar concentration, the more negative this is going to be. That should make sense. The more sugar is found inside the apples, the lower the water potential. Okay, hopefully you guys understand that. If not, please be sure to email me. For your data, please, it says here, use in your results all the data tables you used. I want a graphs or a graph with 2 plots on it. However you want to do it, totally fine. These need to be in your results. Written graphics. The discussion, of course, will either refute, support, or refute your hypothesis. Back it up. Yeah, it's a little redundant, just like you're redundant when you do your captions. You might be saying things in your discussion that you said in your introduction. That's okay. And that's about it. Yep, I think that's about it. As for the lab question, I'm probably going to hold that till Tuesday now and not do it on Monday. I haven't decided yet. I'll shoot that email out once I figure out what I want to do. So, took 6.5 minutes. You still have more than a half hour left to collect your data, and feel free to take a look at this at any time. I will see you on Monday. Take care.